This is a great question. Where you've got a single 12-volt battery and 3 resistors, and you've got to connect them together to figure out what the circuit is where one of the resistors has 8 volts across it and the other 2 have 4 volts across them. The way I'm going to set this one out is there's 4 different ways you could set up a circuit with 3 resistors. So I'm going to set up all 4 ways, so if you came across a question like this in the future, this is sort of the working I would go through. And we'll look through each one of them to see which fits the criteria of 8 volts and the other 2 have 4 volts. So the first way, number 1, is we'll put all of these resistors in series. Way number 2 is we'll put all of these resistors in parallel. Way number 3 is we're going to put have 2 arms of a parallel where one arm has 2 resistors in it and the other arm has 1 resistor in it. And the last way that you could possibly set these up is we have a series and then a parallel. Alright, so we'll go through one of these, each one of these one at a time. Sorry about the awful drawing. And we'll see why, what voltage is in each one. So let's go for a red colour. Alright, this is in series, so the voltage is split up evenly. So because they're the same resistance, 12 volts must be split evenly between 4, that has 4, between 3 of them, so that they have 4 volts each. There's 4 plus 4 plus 4 equals 12. Again, there's 12 volts in this one, so that's not the answer. They're in parallel. In parallel, each arm has the same amount. So in this case, each arm has 12 volts, 12 volts, 12 volts. And again, we're looking for 8 volts, and the other 2 have 4 volts, so that's not the answer either. Number 3. Is there's 2 arms. Even though this has a series inside an arm, each arm of a parallel, just like this one, has the same. There's nothing outside the arm, so each arm of the parallel has 12 volts. There's 12 volts across here, and there's 12 volts across that whole arm of the parallel. Therefore, because these are in series, in each of these single resistors, there's 6 volts there, and there's 6 volts here. So this one has, one resistor has 12, and 2 resistors have 6. Is that what we're looking for? No, we're looking for one has 8 and the other have 2. So the other 2 have 4. So again, this isn't what we're looking for. It leaves us with the last one, but let's just check that that's the case. And this is also the worst drawing I've made. 12 volts. Okay, how do you distribute them across here? To do that, you've got to work out what the total resistance is first. So this is in parallel, and each of these resistors has a resistance of 1000 ohms. So because it's parallel, to work out that total, 1 over 1000 plus 1 over 1000, which equals 2 over 1000, which equals 1 over 500. So our total in this case equals 500 ohms. So this circle here has an effective resistance of 500 ohms. This guy has a resistance of 1000 ohms. Now if you go back to doing question 6, 7 and 8, which are voltage dividers, we're doing the ratio of voltages and the ratio of resistances. This is exactly the same. This section has a effective resistance of 500. This has a resistance of 1000 ohms. So the voltage across this whole circle, we'll call that voltage 1, and the voltage across this guy here are going to be the same ratio. So voltage 2 equals twice voltage 1. Let's do the working over here. Voltage 2 is equal to 2 times voltage 1. So now we've just got to think of what are two numbers where one is twice the other, like 6 and 3. 6 is twice 3, but they also have to add up to give 12. So there's two numbers here, two voltages add to give 12, and this one is twice as big as this one. What are the numbers? The numbers are 8 and 4. So the numbers are 4 and 8. 8 is twice 4, and 8 and 4 add up to give 12. So the voltage along this guy over this whole thing is 4, and over this one is 8 volts, because the ratio of the resistances is the same as the ratio of the voltages in a series. Now because this is parallel, each of these has 4 volts. And that's the answer we're looking for. 8 volts across one, and two of them have 4 volts across them. So there's our answer.